Welcome, and in the next set of videos we're going to look at functions. And we've likely encountered this term before in mathematics, but we want to remind ourselves of the details and kind of the technicalities related to a function. So what we wanted to, at least in this first video, is talk about relations, domain and range, and then also how those concepts relate to a function. And so we want to verify if a relation is a function, and then eventually in the later videos we're going to use properties of functions. And so here we have some more learning steps that we need to do. The one thing I really want to emphasize is that this particular video is both notation and vocab heavy, so make sure to spend some time with learning the language. And so let's just go ahead and dive in. When we look at relations, a relation is really just a set of ordered pairs, and so I notice that I said a set, so that's why we have these curly braces, right? So it's a collection of points, and so this is a relation. We just have, x, y, x, y, x, y, whatever, keep on going, and that's going to be a relation. Okay, then what we do from here is say, well, if we look at this relation, the set of all first coordinates in the relation is the domain. So that is to say, and so this is a set, the domain is going to equal 4, -5, -1. So I'm just picking off the first coordinates. 2, let's back up. 6, 2, -3, 0, and well, 2 is already in here, so I don't need it in here again, and so I would just end like that. So this is going to be the domain. Okay, so generally, if you want to think about this in terms of x and y's, domain is all possible x values. Okay, and then, well, if we have a set of the first coordinates, then we have a set of second coordinates called the range. And so we would say the range here is going to be the set, and then I would pick off all the second coordinates. So 3, 2, 1. I have another 3, so I don't write that. 4, -4. I have another 1, not going to write that, and -2. So when we write domain and range, if there are any repeated values, we don't need to include them because the domain is just domain and range are just a set of all distinct values. And so if you notice these are all the second coordinates, we can typically think of these as all possible y values, if you're thinking x and y. Okay, but now in some instances, a relation might not appear like this to us. It could look at so it could be infinitely many points. It could be a range of points. We could also be given something like either an equation or a graph. And so here, if we remember this is a line down at -3 for the intercept, and then it would go up with a slope of 1. So it would look something like this. And here, the domain, if we think about all possible x values, we would just say that this is all real numbers, and that's my shorthand for all real numbers. Okay, and then if I look at the range, so the range is going to be all possible y values, so I'm looking vertically now, and this ends up being all real numbers as well. Okay, and feel free to use these symbols too. Okay, so domain and range, all possible x values, all possible y values respectively. I come over here, and now I look at this one, and the relation that is being shown is depicted in red, or a dark red-ish. And so if I look at the domain here, it's going to, so I'm looking horizontally now. Okay, I'm looking at all possible x values. The x values, if I look closely, I have all the x values between -3 and +1. So what I'm going to do is actually represent that as an interval, -3, 1, and use brackets at the to enclose this to communicate included. Okay, then range. The range here is, okay, now if I'm looking for all possible y values, I'm looking vertically, and so I'm asking how far do I go down, and then how far do I go up? Well, down I go down to -4, and then I go up to 3, and I have to include all those because I have solid points. So this would be, we could have infinitely many solid points along here. If I had something like a hole, say at 0, I would have to stop this, and I would have to do something like -4 to 0, parentheses for excluded, and then union that or join that with the next interval from 0 to 3. Okay, something like that. If I had holes at a particular y value. Okay, we'll see some examples like that in our class time activities. Okay, so we've talked about domain, range, we've talked about relations, and the last bit of vocab we want to introduce is a function. Okay, and a function, the definition is that every element of the domain, so this is every x value, is paired with exactly one element of the range. So exactly one, and range value, we typically think of this as a y. So if we look at every domain element, it has exactly one y value. And this, graphically, if you think about this, it would have to pass the vertical line test, meaning if we look at a graph of a relation, we should be able to look at a vertical line and say, okay, well, if it's going to be a function, if there's only one y value at that point, because that's what this is saying. We have one y value for a particular x value, and the x value would be denoted by this vertical line. So if it passes the vertical line, if a relation, rather, passes the vertical line test, then it's going to be a function. So then this one, if I look, so I'm going to go through some examples of whether things are functions or not. Here, if I take a vertical line, imagine that's vertical. Not exactly vertical, but if it were exactly vertical, it would hit both, or it would hit two y values for a particular x value. This one happens to be at like 2 point something, -2 point something. So this one is not going to be a relation since it intersects, or sorry, it's not going to be a function since it intersects for a particular x value, it has two y values, so not a function. Okay, the next one we're going to encounter is a little different. So this, you might recognize the shape, but I'm going to say we don't know the shape right now. And so I'm looking, and I look at vertical lines at various places, and it looks like every vertical line that I draw intersects the graph at most once. So this is going to be a function. Now, in some cases, you're not going to be given a graph. So how do you do that? Well, you can either A, make a graph, or B, if you look at the list of coordinates, you want to look for the same x, or the list of ordered pairs. Again, the idea with a function is that for the same x value, there's only one y value. So do I have any repeated x's? Let's go through my list. Oh, I have 2 twice. Okay, so I have this point and this point. Are the y values the same? No, right? I have this and this. So if I were to graph this, I could imagine here's 2 and here's 2, 4, and here's -2, -2. So this one, imagine, let's try that again. This one would fail the vertical line test, so this one is not going to be a function. So again, if you're given a set of ordered pairs, look for the same x value occurring in that list of ordered pairs, and then look for the same y value if it is indeed a function. If it has different y values, not a function. Okay, so this is overviewing this video is meant to overview the language of relation, domain, range, and function. And here are a couple quiz questions for you to test your knowledge on.